Now, if we know that we have a time series and there is a certain level of autocorrelation in the data, then we need to address this when we do our regression modeling to avoid problems of spurious regressions or invalid standard errors. And any model where the dependent variable, where a variable is a function of its previous values, of lagged values, so where y is a function of yt minus 1, is called a dynamic model. But there are different specifications of dynamic models, and that's what I want to talk about here. The first dynamic model I want to discuss is the partial adjustment model. The partial adjustment model you can think of as a relationship between y and x that we expect to hold over time. That's a structural relationship. But whenever there is a shock, whenever there's a change, a sudden change, we can expect there's a delay in adaptation. So when x changes, we might expect that y does not immediately change, but gradually changes. So think of an equilibrium relationship between y and x, and there's a change in x, there's a new equilibrium relationship, but it takes time. It will not happen within one time period for y to adjust to its new equilibrium value. So perhaps you can then model the change. You can say y at time t minus y at time t minus 1, which is how much does y change in that time period, is a function of yt star, which is the new equilibrium value given the changes in x in that same time period, and yt minus 1. So we have a certain distance between the new equilibrium value and the previous value, and we have the new observed value and the previous value, and we assume that the latter is a function of the former, where the adjustment is partial, so less than 1. So this delta in this equation shows you how much less than 1 the adjustment is. Now we can move that equation a little bit around by moving yt minus 1 to the other side, and we obtain a function where y is a function of x times beta, the structural relationship, plus delta times yt minus 1, so the lagged dependent variable, plus some error term, and where there is also where the error term itself is an MA process. Yeah. So you can see already here that there is an AR process and an MA process, an ARMA process built in. In political science, most people who model time series do it simply by adding a lag dependent variable to the model without much further thought. And so what they are implicitly doing without much thought is implementing this partial adjustment model. And while this leads to biased estimates of OLS because of the correlations in the residuals, in the errors, the OLS estimates are consistent. As the sample size increases, it converges on the right answer. Now, the partial adjustment model is actually just one specific simplification variation on what is called the autoregressive distributed lag model, where we have both lagged values of x and lagged values of y. So a static model is where there are no lagged values in the model. An AR1 process is where there is no x value, but just y in the model and a lagged value of y. Partial adjustment is where there's the current iteration of x and lagged values of y in the model. Now, in a model where we add both a lagged value version of the independent variable and a lagged version of the dependent variable on the right hand side of the equation, which is an ADL11 model, we can calculate short-term and long-term impacts. So when there is a change in x, there's an immediate change also in y. But as you can imagine, with the partial adjustment that is taking place, there will be a future impact as well. So this impact is not only in the next iteration. One change in x will also have an impact on y 2 time periods later and 3 times periods later, and so forth. So there is a longer term impact. And it's relevant to talk about the short-term impact and the long-term multiplier. Yeah, so what is the level of change in y in over a very long time period given an immediate change in x? And in economics, when both are measured in logarithms, this tends to be referred to as the elasticity. So when you see in an econometric text reference to elasticity, they are talking about this long-term time series adjustment for a change in a log value on a variable on another log variable. Now, in many models in political science do not have the lagged independent value, but then you can just leave out that coefficient. Yeah, so that is the same as saying that coefficient is 0. You can still calculate the short-term and the long-term impact. And many people tend to forget this multiplier. They simply report on immediate effects. So they report the regression coefficients that come out of the regression after adding a lag dependent variable. but they don't realize that the impact of a change in x on y is actually much bigger than what can be much bigger, can even change sign than what they modeled in the first instance, because they only report on the immediate impact that same time period. People tend to forget to report on the long-term implication. It is possible to rewrite the regression equation. So even though you estimate the equation here on top, you can rewrite the result as follows, and then directly in the equation is built in this long-term multiplier. You can see the immediate impact on the level of change in y given a change in x, captured with gamma 0, and separately you can see the level of adjustment to a deviation from equilibrium from beta 1, and you can see the long-term multiplier with gamma. So this equation really separates out the equilibrium relationship and the equilibrium error, the amount of deviation from the equilibrium, and it shows how then there's a gradual adjustment to this deviation. So the error correction model is a good way of explicitly formulating this mechanism that we discussed at the beginning of this video, where y only gradually adjusts based on changes in x. So the habit in political science of always throwing in a lag-dependent variable and then just report on the coefficients as if it's a normal regression is a very limited way of doing dynamic modeling. It ignores all the other potential specifications, it ignores the idea of an equilibrium and gradual adjustment, and perhaps most importantly, it ignores the fact that the model then implies a long-term multiplier, a slower impact that is generally not reported on.